have asked why in this course we are jumping from one mathematical topic to another. Should the teaching of mathematics not be more systematic? Yes, there is some truth in it. And that's why in every project I state its specific prerequisites. But the goal of this course is not to give you a complete and systematic teaching of mathematics. This course is only intended to be an introduction into some methods for active learning, to give you some ideas of how you can do math with your children in a concrete way. When you understand these methods, you'll be capable of applying them to all the aspects of mathematics which you encounter within a systematic curriculum. Another aspect is that this course joins families with children of different ages. And also within one family, there are children of different ages. We wish that all of them can participate simultaneously in a concrete project. Therefore, it was necessary to include activities of different levels in the projects, from very easy until somewhat advanced. Ideally, you would work together at one topic, for example, operations on the abacus, but every child would do it at his or her own level of understanding. But this implies that as parents we have to be flexible, because at one moment we have to help the older child to solve complicated operations, and the next moment we have to work with a little child who is just learning the numbers. And additionally, we may need to practice our own mathematical thinking. Therefore, we have these different topics within the suggestions for projects. But when the family works together in this way, one big advantage is that the older kids can also teach the younger kids. In the future, I may develop some courses which teach a specific topic in a more systematic way. For example, the laws of arithmetical operations or geometrical constructions. For now, I will give you a tentative curriculum for arithmetics on the elementary level. This is on the stage of concrete operations. This plan is not a rigid sequence, since several topics run in parallel. But at least we will see how the topics of arithmetic are related between them. The base is obviously counting, first with the intuitive numbers, as Piaget called them. This is numbers which do not need any mental construction in order to understand them. These are the numbers until 5 or maybe until 10. Then we can count backwards, and here we encounter already an important principle, the inverse operation. Counting backwards is the inverse of counting forward. Then we can practice addition and subtraction until 10, and step by step we expand the numerical range until 20. Two important principles here are the commutative and associative laws. At this level, it is not yet necessary to use these technical terms, but the child should experience in practice that summands can be interchanged and grouped in different ways without altering the result. Then we can expand the numbers until 100 and practice addition and subtraction with tens and units, as we did in the first project with the abacus. At the same time, we strengthen these principles. Now we see here two other parallel threads. One is strategic reasoning, as used in games like tic-tac-toe, checkers, chess, and so on. This is not directly related to arithmetics, but it is a very important foundation for all kinds of mathematical reasoning. And the other thread is measurement and calculating with measures. For this, we have countless opportunities in everyday life, when you go shopping, when cooking, when sewing and knitting, when doing crafts with paper, cardboard, carpentry work, in sports, and so on. If you make good use of these opportunities, you will hardly need to lecture your children about units of measurement. On the side of operations, we can now advance to multiplication and somewhat later to division. Here we apply again the principle of inverse operations. All of this is still in the numerical range until 100, quantities which a child can easily handle manually and imagine mentally. Then we can combine operations of this second level multiplication and division, with operations of the first level, addition and subtraction. This is related to the distributive law. This principle will become highly important if we want the child to understand later the multiplication and division of large numbers. A marginal subject here are the conventions about notation of combined operations, in which order to resolve the operations, how parentheses are used, and so on. These are actually not mathematical principles, these are notational conventions, but they are important in order to communicate and understand the order of operations correctly. In parallel, we can expand the numerical range until 1000. Take into account that this means not only giving information about new number names. Every expansion of the numerical range is at the same time a challenge to the child's capacity of imagining larger quantities. While this imaginative capacity is not developed, the names of numbers will be meaningless to the child. At this stage, we should also focus on a better understanding of the decimal system and positional value, as we did in the projects for Module 2. This is in turn related to the conversion of measurement units in the metric system. Another topic in this context is commutativeness of combined additions and subtractions. We know that subtraction by itself is not commutative. 7 minus 3 is not the same as 3 minus 7. But there is a kind of commutativeness which applies when we treat each number as united to its respective sign. In this operation, for example, we add 5 and subtract 8. This is the same as subtracting 8 first and then adding 5. This is an important preparation for understanding later how to use signs correctly. And we find the same commutativeness also in the combination of multiplications and divisions. This is in turn an important foundation for understanding multiplication and division of fractions. Now we arrive finally at the point where it becomes meaningful to introduce sums and subtractions of large numbers vertically, and later also long multiplications and divisions. And in parallel, we can go on expanding the numerical range slowly until 1 million. A side note here, in several textbooks I found vertical subtractions written this way. This is wrong. It may look like an unimportant detail, but because of this detail, many students will never understand the laws of signs. The number we subtract is 218, so this is the number which should have the negative sign. The 630 are what we have, so this is a positive number, and students get confused when they see this positive number associated with a negative sign. Also, according to our notational conventions, the sign goes before the corresponding number and not after it. Therefore, in the former example, the positive sign belongs to the 5 and the negative sign belongs to the 8. So please put the signs in their correct places and avoid confusions. Now, when the children understand multiplication, it is time to introduce several concepts and principles related to multiplication and division, multiples and divisors, prime numbers, factorization. And later the concepts of greatest common divisor and least common multiple. There was no time in this course to talk about these topics, but maybe you wish to choose one of these topics for your free project in this module and to find some activities with concrete material in order to teach this to the children. Related to this is also the concept of proportions. This is best learned in our everyday activities, calculating prices, proportionally increasing or decreasing the quantities of ingredients in a recipe, interpreting maps, estimating times, speeds and distances. There is a surprising number of everyday situations related to proportions, and this is a much better approach than the theoretical concepts of a textbook. Graphical representation of quantities is also related to proportions. After all this, the child will then have a sufficient base for understanding fractions and decimals. Even before, they can understand simple fractions of everyday use, such as a half, 1/3, 1/4. But in order to master systematically the operations with fractions, it is necessary to understand first these concepts related to multiplication and division, since a fraction is the same as a division, only written in another way. Particularly, the concept of equivalent fractions is closely related to proportions, greatest common divisor and least common multiple. So we should teach these concepts in their respective context and clarify these principles, and then the children will realize that they can use in the context of equivalent fractions what they already learned with proportions, and vice versa. This way, children do not need to accumulate a large quantity of isolated facts in their memories. Instead, they can perceive mathematics as a whole, where almost everything is interrelated, and a discovery in one area sheds light on other areas. Somewhere here we can accommodate the topic of percentages. A percentage is a special case of a decimal number, and at the same time it is a fraction, since percent means hundredth. So we have to put it into this context. This is almost everything a child in the stage of concrete operations needs to learn in arithmetics. And these topics cover practically all the needs of everyday life, except for professionals in areas where advanced knowledge of math is necessary, such as engineers, scientists, computer programmers, and so on. But in other professions, you actually don't need much more math than this. I know that many school curricula and many textbooks are much more demanding than this, but we do not do any favor to children when we force them to advance faster than they can understand. The more advanced topics are much more easily learned when the capacity of abstract reasoning awakens, which is in adolescence. Some topics we may perhaps add here are these: negative numbers and the laws of signs. This has in turn some implications for multiplication and division of fractions by fractions, since the laws for operations of the second level, multiplication and division, are completely analogous to the laws of addition and subtraction. Addition of heterogeneous fractions is an even more advanced topic, although it appears in almost all curricula for primary education. But an investigation found that in order to actually understand addition of heterogeneous fractions, a mental age of 14 to 15 years is required. We could include also powers of whole numbers. There are some practical ways to visualize this with concrete materials. Now, this is not a strict sequence. We have seen that many topics run in parallel, so it really doesn't matter which one of them you treat first. But yes, there are some which are required in order to understand others. And of course, in parallel, we will also teach topics from geometry, perhaps some set theory, and others. You will have noticed that this plan does not mention ages. This is because each child has its own pace of development. So we should not make the topics dependent on a child's age, but allow each child to advance at his or her own pace. When a child masters one topic, let him or her advance to the next one, no matter whether this happens at 6 or at 9 years of age. If a 10-year-old masters everything in this plan, let him or her go on to the more abstract subjects, roots, algebra, etc. On the other hand, if a child does not understand some of these topics until 13 or 14 years of age, be patient and allow him or her sufficient time to mature. It is still possible that this child will take a big leap forward in later years.